Okay, hi everyone. Welcome to Always Coding. This is our weekly Hacky Hour. Today's focus is going to be on how to deploy computer vision on OAK cameras, so specifically the OAK-1 and the OAK-D cameras. I'm Komal Devjani. I'm a developer advocate with alwaysAI, and I'm joined today by Steve Grisette, who is the CTO of alwaysAI, and Taiga Ishida, who's a software engineer at alwaysAI. So welcome, both of you. Before we get into the presentation around how to deploy on the OAK-D, we're just going to get started and show you how to get up and running with alwaysAI. So let me share my screen. And we're going to go on to alwaysai.co and navigate into the dashboard. So if you can't access the dashboard, you need to sign up. And the first place you'll be navigated to is the dashboard. And here you'll learn information about how to train a model. And I know some of you are actively using the model training toolkit. So if you have any feedback on that, just let me know. You can create a project and install the CLI. So you can click install CLI on the dashboard, identify your operating system, hit next, and click the big red button that says download for macOS or anything else you're using. So what I'm going to do is run a project. So I've created one for Hacky Hour, and we're just going to demo that. So you'll know it's working if you go into your project. You can change your models here by adding new model, going into the model catalog, and just adding the specific model you want onto this project. I'm okay with using the MobileNet SSD, and what we're going to do is just configure this into our terminal. So you can open up a directory, make a directory, and then paste this in here. And then we're going to do AI app install. And then we're going to do AI app start. So just following the instructions right over here. And as you can see, this is going to show me all of the labels this model can identify, and you just want to copy the URL and paste it into an empty web browser. And as you can see, it can identify all of the various things in this room, my sofa, my plants, my TV monitor, and that's MobileNet SSD. And so today's topic is deploying this on the OAK cameras. So Steve, if you'd like, we're ready for you now.
All right, well, I'm here. I'm ready for you guys too. So hello, everybody. Let's see. I think we should get some slides up here real quickly. So a little bit of a conversation. The OAK cameras, the very successful Kickstarter program that came out with OpenCV sponsorship. They're made by Lexonis corporation. And what they do is they embed the Myriad chip into the camera itself for doing inferencing and so forth. And they have two varieties. They have an OAK-1, which is what I'll be showing today and doing my demos with. And that is just a straight up camera with the distancing. And we'll get into more details of what it's capable of. And then Taiga will be showing the OAK-D, which I think is the famous big brother of the OAK-1, to put it on that has the spatial AI capabilities on this. So with that, why don't we, this is a nice introduction. Let's move to the actual slides there. So let's just talk about the agenda. We'll just do an overview of the OAK cameras, the one and two. And then we want to go into some coding and so forth. But in that overview, I'll talk a little bit about where to find things in our documentation, some of the neat things that we have in the alwaysAI platform to support this. On the coding, I'm just going to go through the basic usage of the APIs, and that's going to be using the OAK camera. Doing a facial detection application with our correlation tracker. Then I want to do one, because object detection is kind of boring, we've all seen it a couple of times, so I decided to spice it up. So we'll try to see if we can make the OAK-D see in color in a very basic, and show a very basic computer vision algorithm about how to establish what color the pixel is and so forth. Then what probably everybody's been waiting for, we saved the best for last. Taiga is going to come in and do a spatial AI demo using the OAK-D. I only have the OAK-1 at my house, so Taiga is very privileged. Also, Taiga is actually the one who did all the coding. I've been an end user. It's been quite fun and experience in building the Hacky Hour in the end user role. So I've been doing how you guys would go and take a look at the program with not or the software without getting any special looks. But the low level coder and the person that knows everything about it is Taiga. So it's good to have him. And he created the APIs working with Luxonis on it. So it's good to have him here today. So Taiga, it's glad to have you. So that's the agenda, and we haven't lost anybody, so that's good. Hopefully, if people will learn something. Let's go ahead to the next slide. And to support this, we just did an EdgeIQ release, and I wanted to quickly walk through that. So we released 1.20 on Friday, and if you have the desktop, you just need to start up the desktop, and it will go and look for updates, and it'll put on the top of that there's an update there for EdgeIQ 1.20. Go ahead and download it. And so what we've put into this is we have full support for the OAK cameras, and so that's the inferencing and on RGB, the red, green, blue APIs, the spatial AI APIs, and then the custom model workflow with the CLI. So what you're able to do with this camera is go ahead, create your models using the model retraining tool, and then what you can do is convert it over into an OAK blob, which is their format for running on their inferencing engine down there, the Myriad inferencing engine. And you can go ahead and then publish that model and use it in your OAK-D applications that you have and so forth. So one of the things that everyone knows, we went to Commerce and we started locking up the model training. Well, Como is a really good developer advocate, and she came and talked to us. And so we're actually, as part of the going to be opening up real soon again, the model retraining. So all of you can use it on your projects and things like that. So we're giving that back to the community in the Freeman offering and so forth. So again, it's when you go to Commerce Model, you learn things and so forth. So we want to make sure that's available to you guys. So we're going to go ahead and do that. Next slide. So everyone thank Como on Discord. So let's just the basics here. So the top one is the OAK-1 that I'll be using, the top camera, nice little heat shield around that. The lower one is the OAK-D. Also, it has a heat shield, but some people will go and there's places that sell the raw cameras without the heat shields on it. So you'll see those out there too. But if we go take a look at the image sensor, this is running, the OAK-1 is running a Sony IMX378. A sensor, if you go to Sony's page, you can see this. It was one day, it was state of the art in the cell phone industry. It isn't today anymore because cell phone industry is, way up here on camera releases. But what it is a nice leapfrog. So we all use the Pi cameras. The Pi cameras are based on an IMX219 sensor. And so even it's very old sensor, but it's max frame rate on the compared to the 378. It's max frame rate at 30 frames per second. This one can get up to 60 frames per second. You're dealing with something that has 2 megapixel resolution in the Pi 2 one camera on that thing. This one can obviously get up to 12 megapixel resolution, and then both of them do have autofocusing. The OAK-D is sporting an OmniVision camera lens there, and it can get up to 120 frames per second. It has, and again, this is for the AI stereo camera type usage. It has the 1 megapixel, and these are really the stereo cameras I go in. I believe, and Taiga can correct me, that its main camera is just the same as the OAK-1's. I think that's right, Taiga, right?
Correct.
Great. So when I have this OAK-D, these are the specs on the stereo cameras that will give you the distance piece, and they're an OmniVision 9282. If you're into that thing, you can go look at their spec sheet on that. It can operate about 120 frames per second max rate. It has a fixed focus And then again, this is on the distancing center and 1 megapixel. So really nice cameras, really big step above what we're used to running on the Pi cameras. So any questions so far? I know that's a lot to throw out there, but those are the basics.
So we don't see any questions yet.
Okay, either you're asleep or I've done a good job. Don't know what. Let's go to the next one. Let's get started. So yeah, now let's do the fun. Let's get into code. So next slide, please. Sorry, Kamal, appreciate you doing this. So we're going to go through the basics and just really quickly, and then we'll get to real code. The supported inferencing that we support on this is classification, object detection, and pose estimation. Let's see, the API information, and we'll go there. It can be found at that link, and I'll go ahead and I guess I should paste that in, or maybe you can paste it. Komal, you're better at that than me. The face detection and what we'll be building is a face detection application, and we're showing the correlation tracker. And what we've done with the we've done some refactoring on the correlation tracker, which I said correlation. We're going to be using the centroid tracker. So there you go. I thought one thing and wrote one thing, but I'm actually going to use the centroid tracker today on this. So ignore that slide. It's wrong. And then we're going to count unique faces using it. And the reason I want to do that is with the 1.2 release, we have changed some of the parameters and everything in the trackers. We've done a lot of refactoring of the API. And what that means is we're going to get ready to work on trackers here real soon. So we'll be seeing Kalman filter trackers come in. We'll be improving the correlation tracker and the centroid tracker and so forth. So any questions so far? Kalman, I see some chats coming up. I guess we have one.
Yeah, so it says, are these cameras ready to
answer to the question? But yeah, it can be used in the real world.
Great. And then the next question is, so this one says, I'm still not clear on the relationship between alwaysAI and OAK. Does OAK have their own modeling capabilities? And does alwaysAI replace these?
OAK does not have its own modeling capabilities on that. We're one of many companies that support the modeling capabilities. We also support the deployment and so forth of the applications and the ability to use the camera through those. So we have kind of an end-to-end workflow system on it. So the relationship is we support that workflow and the ability to push your models to that, create models for it, and so forth.
And then AB says hi.
Oh, AB, hi. on it. So good to have you here. By the way, full disclosure, AB, we have an expert in the community on this. AB fully, well, he got in early with a team, and they went ahead and used the OAK-D cameras right in the Kickstarter program. They got some shipped early on, and he and his team were like second place winners in a really interesting application on managing containers and how to fill them. And so he's the real champ here on applications. So if you're in the community, I'm going to get, AB, I'm going to get you some people contacting you. So if you have some usage on these, AB's the real expert. I'm going to do some very basic demos today. Nothing like what he did and his team. So
AB just said, thanks for the plug.
All right. On it.
There's one more question.
Okay.
It's saying, are you using OpenCV's APIs for OAK?
No, we're using our APIs for OAK.
Okay.
So.
And then Akshay says hi as well. Hi, Akshay.
Hey. All right. So let me go ahead and let's stop the slides, and we'll come back after the first one, and we'll go through and take a look at stuff. So I guess I have to do that. Let me screen share here. So hey, look at that, a little button on the Mac. Let's see, did it work? No, it didn't work. Did it share my screen?
No, it didn't. You should be able to share your screen.
Well, I'm gonna have I'm gonna talk to Tim Cook about that. All right, so here we go. So hopefully you can see the alwaysAI desktop. So quickly, what I wanted to do is just show you where the docs are and everything, and then we'll get started. So if you go in first around the model retraining, oops, I didn't want to actually model retrain. I want to go to docs, as I said originally. If we go into model retraining and you go into additional resources, here we go. And we look at, where is it? OAK, where's my OAK? Huh, I'm getting stumped. I thought, is this running train? No, that's not running train. Okay, maybe Tyga can help me out here. So this is not where to go on the API. So let me make sure it should be model training. Let me make sure I did additional resources.
Using your model, it should be under using your model.
Ah, okay, thank you, Tyga. Use your model. And then you can see we have the OAK camera support. And from there, you can see if you want to, so you're doing all your workflow, you have your artifact, your mobile SSD, let's say model version 1, and what you can do is just go ahead and enter this model convert, and it will create the blob for you. And then you go ahead and publish it out, and then you can use it in up to the catalog, in your private catalog, and you can use the application there. Also around the catalog, if you go into the catalog and say you choose, like I said, we have different models. Let's just show on detection. If you come up and you say OAK, you'll see that we have a series right now of 3 different models up there for the OAK-D. There's a pose estimation. I don't think we've gotten to classification yet. We'll have classification, but we'll continually add in the different categories to the OAK-D camera piece. So on that. All right, so let me go to a different place. Let's go to alwaysAI, get. If you go to the GitHub real quickly, and so you can do this with it. We have now 2 repos. One's our official starter app repo, and you know, Tyga will be showing you one of these applications in here today, which is the depth stream one. The using models has the pose estimation for people that want it. Our Hacky hour is going to be around OAK cameras here on this one. So you can go through this repo, and we'll be using, this is one I'm going to be working with right now, but and downloading it. But basically it has the two different ones, and I'll be adding it going forward. The 2 different ones we'll take a look at today. So if we go back into here. So for those who want to join along, you go ahead and we'll copy, and we'll go into, let me go ahead and move this forward over here. Got a lot of stuff going on today. So I think I made it big enough for everyone to see. So we'll just do a git clone, and then I'll paste this in, and we'll get started here. All right, so we should go into, let me make sure, into the camera repo, and there we go. And then we'll see that we have our two basic things in there, basic and detect. Let's quickly, before we go ahead and well, let's go ahead and we'll walk the code, but let's first see the results here. We'll go ahead and start our alwaysAI app configure. Well, actually, we'll move into one of the repos itself that has the applications. That's probably the smart thing to do. Start with the basic. And then we'll go through the fundamentals. So this one, I'll just create a project. We'll just call it basic Hacky. And so we're going to go to a remote device, and we'll create our Docker file. So the usual workflow that you're used to. I have my Pi here. We're going to go to a Pi 4 today. And we have that updating tokens and so forth. And then, yeah. So I hope the demo gods are with me, and I'm not going to do it. Last night I managed to, when I was practicing some stuff, I managed to trash my Docker daemon. So I'm hoping that doesn't happen again. So let's all keep our fingers crossed. Hey, how about that? So, okay, so somebody didn't turn off. And so let's go through and do a start. Not sure why we always get that warning, Tyga, but maybe. And so if we look, let me go over here. I'm always maneuvering around so that you guys can see what's happening. We go 192. Yeah, there we go. 5.4. So we've got facial detection going on. Sorry, we got some sunlight that's in the way, but that's part of the real world, right? So if we take a look at it, I don't know why Mr. Stewart doesn't want to come up. If I do this, get a little bit more light on. So now I have 3 faces. No, it thinks it emits its face. So anyway, well, there I got cute with the bobbleheads, and it's not working as well as I want it to. So in the facial detection, come on, guys. So this is basically just running the face detector you've seen. We now have 9 faces. So what the idea is using the correlation is to count the faces that come in, but I'm getting some real sun problems. I may want to draw down the blinds, but anyway, it counts the faces as they come in with the correlation, the unique faces, and then it'll time it out as it exits and so forth. That's what we're trying to do with the app. And if you come in here, boom, there, you should see another face in there, and then it'll exit out. And the face count will go around there. And that's, so you can see the OAK-D is pretty fast on it, and it works really well. But let's take a look at the code real quick on it. If there's no questions, there shouldn't be. I mean, pretty straightforward on that.
There is a question actually, Steve.
Okay.
But it might not be related to what you just presented.
Okay.
The question is, how can I make a private model public? So how to make a model public in the private catalog?
Yeah, we have not. So the best way is to contact one of us and we can put it up in the catalog for you. That's what we've been doing. We've had, first robotics groups and things like that we've done that for. We have not. That's a feature we really want that we haven't gotten in. We need to get that feature in there for it. So if you just contact us on Discord, we'll do that. We'll put it up in the public catalog for it. Hopefully that, but if you're using our model retraining, you don't want to go into our catalog, you just want to make it out there. You have all the artifacts to do that. So you just need to create a Git repo on it. So there's 2 answers to the question. One, if you want to put it in our model catalog, which we welcome, we can go ahead and do that for you. If you want to go ahead, you'll have artifacts from our model retraining. You can build your own repo and put it up there too. So. And if you need any help in those processes, we're here on Discord to do that. So let me go ahead and busy up here. I got too many stuff. There we go. Bring up my friend Adam. And I'm not going to work in that repo. Let me go to a new window. That would be the one that affects everybody. So I'm not going to do that. So my New Year's resolution was to get rid of lint errors, and flake 8 errors in my code. So that's why that's popping up like it was. So I'm going to here. Oh, let me go find my OAK-D cameras. So let's go into basics. So if we take a look at the code, sorry this took so long. So if you take a look at the code, you notice there's no lint or flake 8 errors. So being reported. So doing some things good. But anyway, so we take a look at the Centroid tracker now. And this is where we're calling it in the code. So basically, if you notice, there's a couple things going on. We don't have all the big preamble. Remember how you have to have start the object, things like that. So what Taiga did was he wrote it in a context manager format design pattern when he created his interaction with the OAK-D camera, which we've used for many of the other starting the web camera. But the good news is this will also start all the inferencing, all the stuff behind the scenes. So you don't see the big preamble of loading the thing, what's my accelerator, all that type of stuff in this code. So if we go to the main, but we do have, and what we put in both the centroid, which is what we're using today, not the correlation tracker, and the correlation tracker, some of the parameters we've added is actually callback. So if you notice the code we're running, I had a callback to a function that basically will say, hey, what's an entry event and what's an exit event? Now, I'm doing something that's pretty basic here, just to show, and it's just printing up on the screen saying, hey, a face enters, a face exits, right? On that, but you could do, you think about it for your applications, if you're trying to write a more advanced application, some type of analytics, some type of awareness that goes on those callback functions, you can write more, you can write whatever code you want. You'll have max objects. The other thing that I don't have in the code line, if we went to the docs, is there's also how many seconds or how many frames should I go when an object is in there when I eliminate them from the tracked object database or list, excuse me, on that. So we have that in the parameters, but these are some of the new functions. I think we've had the other two functions, but these are the two new, I should say, parameters in the tracker system. So it's kind of nice. It allows you to put them do actions in your real world app when something happens with the tracker. So this is the start. As I said, it's context manager. So context manager can start several devices if they're in that format. So we're going to start the OAK and the streamer. Some of the core parameters in the OAK, there's really 4 that I would say that are core in the API. I hope that doesn't out of the 5. But the first one is, this is where you would enter the model you're going to use for inferencing. Hopefully you can see my cursor. Can you see my cursor, Como?
Yes, I can.
Okay, I just want to make sure that I'm not out there in Steve land, right? Having a great conversation with me. But so anyway, so that's where you enter the model ID that you want to put in, and then on the sensor ID, this is where you do the different resolutions that the camera has. You can set that, and you can set the video mode either through preview, which is what the inference engine is going to see as a frame, or on video mode, which is, I think using the resolution to its full capabilities on the camera. Taiga, you want anything to add on that one?
Yeah, so I think you explained it, right? The preview shows you what's going on into the inference engine, and then video mode, video will just show you what's coming out of the raw sensor. So you'll get the full resolution image from when you call get frame.
Then the other one that I didn't have, that I didn't list in here, and I should do it, and I will go back and do it, is your USB. We default to 3.0, and if you don't tell the parameter, but you can also, or USB 3, I shouldn't say it 3.0, I don't know what, but it's USB 3 version. And then you can operate these cameras in USB 2 mode. And that's the other parameter. And I'll go and update this after, in the repo to put that one in there so people know how to use it. But it's in there. So if you do plug in, like, say, why would I do that? Well, let's say I have a Pi 3B plus and it's only got USB support, right? So, I have a 2. And so the camera allows you to do that piece. Then we just do the FPS start. And we come in, and one of the parameters is, so now, I've instantiated my object, my OAK object as an OAK camera, right? So the first thing I want to do is get my frame. And so we have a command, get frame, right? So on it, I get my frame, and then I want to do my inferencing. So what I do here is I actually get the results from the OAK camera. Now, normally in our inference engines, we support a blocking mode. So if the results is null, it doesn't matter. It just goes through the process. And this is one of the things I learned that Taiga trained me, even though he has it in all of his API documentation. I ignored it. But what you need to do is test for the results, because the OAK-D camera actually returns a non-blocking, so it will return a none type. That really causes problems throughout the rest of your code. You can check for none too. And that's what we're going to do. So if you do have results and they're not none, then you want to go through and do all your processing and so forth. The other thing is I stick the FPS update because I really want to know what my frames per second is with processing, not, hey, look, the camera's running at 30 FPS, the camera's running, who cares, right? We'll care next week when I do high definition cameras, but not this week. So anyway, so you go in and then it's pretty much all the same. What I'm doing now is I'm loading the tracker. And so I'm taking the results update and loading that into our tracker. So, we instantiated our tracker up here in the main. And then what I'm doing now is as I get prediction results and so forth, I'm updating the Centeroid tracker information. And then I just go through, and this is going through the predictions with the tracker and putting up what we see going on to the streamer on the left-hand side of the panel. So that's it. So the only real so it's actually a lot neater than average object detection. So well done, Taiga. And then the only thing is that blocking situation. I don't know, Taiga, anything you want to add on it?
Yeah, we could. So I'm kind of working in if we want to have a parameter here in the get model result, like we can have a call type to be blocking or non-blocking. That's something I'm kind of working out is
okay.
If I want to present that to the users. But yeah, so the way it kind of works, you can't expect the frame to come back at the same speed as the inferencing result. So it's kind of, that's the behavior here. But, in the future, I'm looking into kind of making, each of these calls blocking or non-blocking, and that's can be user specified.
Yeah, so we keep it in sync. So yeah, that's the one difference and the one gotcha, because I was like, hey, Taiga, it's dying. And he said, you didn't read the docs. And I didn't. I got myself in trouble. So any questions thus far?
Yeah, so this is a question about IR cameras.
Okay.
So the question says, I have an application with privacy concerns like bedrooms, so cameras won't work. Can I use alwaysAI models for IR cameras and get pose estimation and distance functions?
So the answer is so the answer is yes. On the IR functions, we on infrared we did do a FLIR lepton. And so I think in a couple of weeks, I'm going to be updating that. So you can use the basic structure on accessing the FLIR lepton, and it's in one of our repos up there. There's a Hacky hour we did on that. So you can go into the infrared on it. Now, that particular camera doesn't do distance and so forth. But I think there are distance cameras out there. Taiga, I think the Real Sense can probably do work in IR mode, which we support, which is a distance camera. So from Intel. So I believe that can operate in IR. I'm not sure on it. Maybe AB or somebody knows on that one, but the answer is you can get there. FLIR is a nice one to look with. Infrared cameras are expensive. FLIR is an expensive camera. They have a Bison camera that hopefully we'll put support in someday. So getting an end user to use the Bison camera, but it's going to run you about $2,000. The Bison camera, and that has a Myriad processor tied to it, so it would operate similar to this OAK-D and so forth. And there's probably some games you can play with heat, right? On distance and so forth. I don't know, expected heat, things like that. So the answer is yes. May take more creativity, and then definitely tell us about the camera you're using, and we'll try to support that camera as we get usages on it. So I love supporting cameras. So.
And then the next question is, does your API completely replace the Luxonics Depth AI API?
So I'm going to let Taiga answer that. That's getting down into the deep. It certainly makes it easier, but let Taiga answer that one.
Yeah, so there's a lot more advanced features that they do provide. That's kind of, I know they have like the capabilities to add in image manipulation nodes and stuff like that. And, I think those stuff we can work in, but right now what we cover is just, creating a depth node, a color stream node, and a neural network node. So we can't 100% replace them, but, that's something like that's gonna come down the line. I think it's like as we see more users and requirements and stuff like that, we can definitely add in more capabilities that Exonus provides into our APIs.
You can import their library though and tap their functions, right? If you wanted to in our platform, because you have the base stuff down in the container, right? You can import their depth API, right?
Yes. And also if you know how their pipeline stuff like and the pipeline objects work, the OAK class does have the pipelines exposed, I believe. So you can also add in your own nodes to their pipelines.
Yeah.
If you know how
to do it all within the container management system. So what we're trying to do is make it easier, fit into the workflows and so forth. But what we're not doing is saying, you can't use the depth API and alwaysAI. You can use their depth API. So,
Right. Okay. That was the next question. Can they work together? So
yeah, they absolutely can work together.
sweet.
So yeah, we don't want to take away that. It's just like you can use CUDA out in the NVIDIA if you want to, and so forth. So we don't want to stomp out some of the goodness that vendors put into their products. So on that. So let's
suggestion here, Steve,
yeah.
before we move forward. So AB says you could use the requirements.txt file to add the depth AI library.
Yeah, I think it's already in there, AB. That's what I was asking Tyga. Tyga, right? We've included it already, so you just have to import, I think.
Correct. Yeah, they're in the containers as well as being installed in the desktop.
Yeah. So that's the good news. You can do that. You can use the requirements file and so forth, but you don't need to, right? It will just tell it's already installed. But it's a good way to update it too, if you want to on it. All right, so let's move on to the next one. So can you get my, no thanks on this. I'm gonna kill you. All right, so let's go ahead and try the next one. This should be interesting with the sun. It works great at night, the next one. So can you bring back up the slides real quickly?
Yeah, sure.
And go through what we're gonna do and we can talk through it. And while you're doing that, I'm gonna reset my stuff. See if it will work better. We're getting rid of bobbleheads right now. I can't wait till COVID's over with. You don't have to do this anymore. All right. So sorry, people. Prop change. Okay. Is it up?
Yeah. Can you see my screen?
I can't see it, but that doesn't mean other people can't see it. It just means that I'm lame. I don't know why I can't see it.
Navigate onto Zoom, like the main.
Yeah, that's what I'm doing on it. So anyway, let's, okay, so I hate this type of stuff. This is why I need to not do my homework at night. There we, nope, that's not it. All right, I don't know. Where's my Zoom stuff?
Let's try again. Are you on Zoom, Steve?
I am on Zoom.
Can you see it now?
Let me do I guess that's the gallery. No, one of my windows went away and I'm not sure where it's at because I have split windows and I don't know where it's at. So, but I did write the slides. So let me go ahead and I'll talk through them.
Wait, Tyga, can you see the slides?
I can see the slides.
Okay. So anyway, so the next one we want to do, and like I said, this is one I just wanted to have a little fun with, is seen in color. So the idea is let's do some object detection, and let's go ahead and see if we can figure out what the predominant color is in the object. And really, this is just kind of having fun. What here, the thing is, this probably works much better with, well, it works much better with homogeneous colored things. And what we're going to do on this is, basically, in computers, we all know that, well, there's 3 primary colors, red, green, and blue. And we all know in the digital side, we go from 0 to 255. And then if you took a look at that, that would mean there's about 16.5 million different representations of colors. But the truth is, computers can't do all that type of stuff. There's some other limitations and so forth. And the good news is on the data set side, and it really gets limited down to about a little less than 900 colors that are meaningful and so forth. And then fortunately, people have created data sets on this already. There's a lot of them out there. I have a Git repository for that. The color CSV is in the, that somebody has created on this. And the color CSV file is up in the repo. So it's part of the, as you bring down this repo to work with. So basically what we're going to do, and I'll move down to that next slide, please, on the scene in color. So first of all, let's talk about the dependencies. So in this case, you do need to install pandas. And the great thing is that if you want to do these, it would be hard to follow along on a Pi because it takes a long time to install pandas on a Pi. But anyway, the requirement.txt file, as AB pointed out, with this repo has the installation of pandas. So what is pandas? Pandas are really the way Python world can work with CVS files. So you can go in there and manipulate them like they're spreadsheets and do different types of programming on them, making that type of output very programmable in the spreadsheet format and do different things on it and eventually use it if you're using with Matplot, being able to plot and other tools and so forth. So if you're into the data scientist area, learn to use pandas. In this case, we're just going to use it to get the CSV to find out different colors. And the algorithm we're going to do to estimate colors is, using the alwaysAI APIs, we're going to get the centroid pixel of the detected object. And then we're going to take that pixel and we're going to use a distancing algorithm to find out, to calculate what the distance is between the red and go through that spreadsheet to find the shortest distance, and that shortest distance should give us the color on it. So that's what we're going to do. It's just kind of a fun way. It's not as accurate as one would think, but it's just kind of a fun algorithm to use, and it's one that in Computer Vision 101 you'll get taught. It's used, I think, a lot with probably people editing images will use this algorithm and so forth to know what the pixel colors are and adjust them and so forth in a full-blown application. So that's what we're going to go ahead. So now we can all screen share again if we're okay with that. Okay. Continue. Share. All right, so we're back to the screen. Kamal, can we see the screen?
Yep.
Okay, got it on it. So let's go ahead and have some fun and start this application. Get some interesting colors, and like I said, I'm going to have some nice lighting. Night's the best time to do this one. So we'll go ahead and we'll do the configure. And then we'll get quickly, I promise, over to Taiga. So I'm going to go ahead and create a project called and we'll use that remote device again and set up our Docker file. The other way you can install pandas, and I do it within our system and actually right into the containers, you can put a run command, a run pip install in the container also if you want to do that. And the reason I like to do that is, and I know Lila and I will go, what's the right way and so forth. In Pythonic way, requirement.txt is the right way. In the AI world, always AI world, I like the run command, and because we're not verbose when we're setting up that container, so you don't know what's happening. So if you have a long running process like installing pandas, I should keep talking and move here. You just don't get feedback on it. So that's why I go the direction I do, because I can see what's going on because it's a verbose mode type of system. So it tells me the steps. So Lila's right from the Python perspective. It's the correct way to do stuff. So, and I'll explain more about as we come through this thing, what we're taking a look at. I mean, once we get there where it is, right after this Docker setup happens. So this one's going to take a little while. I'm moving CVS files and things like that around. So Ty, this is what I'm talking about. It feels like it's getting slower on the release sometimes, but the other one ran fast. All right. It could be my Wi-Fi. I don't think anyone's all right. Any good jokes?
I forgot to get that book of jokes.
Yeah, so here we go. It finished. I'm not sure why it took that much time on it. I'll have to look into it. We may have a bug issue, or like I said, maybe I haven't gone and checked around the house. Somebody's streaming in the house some videos. Maybe I got Netflixed, and that's the problem. So I'll have to try it. I probably should learn and just hardwire it into a Ether cable. So on that, but this one, I'm not really sure what it's up to at this point in time. Come on.
Have to give it a little light tap on the top of it, like the old days, just give it a light tap and it'll move.
Hey, there we go. So right here where it's installing the dependencies, as you can see, it's not in verbose, and that's why I don't like to do it. And hopefully, so I already had pandas, but if you have something like pandas and it's something that's big, I think Flask and others, I just like to run them from the run because you see them. People skip it because they're running on their Macs and things like that. It's much faster process. But anyway, that's to be debated. It'll probably come up in see, there's a quiz. When we do the quiz and we give away the Amazon card later on in the year, include that one, comma, why does Steve like to use?
Noted. Got it. Noted.
So we'll get started again. And again, this time we're running the mobile SSD model. And let's see, we have our bottle. It thinks it's Oxford blue. We see our cup. I don't know why it's stopping. Well, I don't know why. I don't need to interfere with it at all. But anyway, so it thinks the cup is olive drab or brisk. And I guess with the lighting, it's kind of is. And so dark green, I don't agree with that one. I don't know where it's coming in. There it goes, Oxford blue. But anyway, it's a kind of a fun way to do color analysis. It's not ideally accurate or things like that, but you can build on the algorithms if you really want to do this in a more professional way on it. So just for those, that cup is supposedly supposed to be bone, but that's what the manufacturer, but lighting does matter. It does think, there we go, get to Oxford blue. Let's see if I can get it more in the light. So like I said, it works much better at night. No, it still thinks it's dark green. All right, what do you think the slow model is? Let's try to change some stuff. This is running at a lag, Tyga. You can see I've already done and finished with this. I don't know why it's at a lag. I think this is Wi-Fi problems today. There we go. Get to see the past. Smoky black, okay.
AB recommends you can set up a QoS level on your router. QoS level.
Yeah, I think you're right. on that. So anyway, but that's it. That's just a little color detection. It's a core algorithm. Like I said, when you go in like your first week of computer vision courses, they'll say, hey, run this. And fortunately, the data set file is out there. So you don't have to set one up and figure out what colors look like and things like that. You can just study it. So let's go ahead and we'll take a quick look at the code, and then we'll, and we all know you're waiting for Tyga, and we'll let Tyga come in with that. But quickly, this is a function. You're basically going in and you're calculating the min in it, and then you're going to go ahead and you're going to find all these minimal values, and it eventually will kick it out. And yeah, I'm not lint. So anyone wants to see I have a lint error there. So sorry about that in the code. But anyway, that's just a styling error for everybody. Like I said, I'm trying to improve my style. But anyway, so what you're able to do then is get the color name. So what the process is, so that's the key algorithm is right there. And like I said, this one is out there all over the place on the algorithm. You're just finding the distances, and once you have it, that will give you your color name out of it by the CVS file. Up here is just really how you index and read in the CVS file itself on it. So it's a very basic intro to pandas, the most basic things. So again, if you look at it with the OAK, we're getting our model in. And loading up, and then we let it warm up, and then we start our FPS monitor, and it's the same thing. We get the frame and the results. What we're doing a little bit different, if we go down to the predictions, so within the alwaysAI APIs, we have a lot of stuff around bounding boxes that we have for people to use on their applications. And so I'm going to take advantage of it and get the centroid pixel. And that's what this line right here does. And then once I take it, I go ahead and I take those pixels coordinates. That's what center is. It's the center pixel. I go ahead and take that pixel. Remember, I'm now, the pixel is in, well, it's going to be, because it's OpenCV. I think if you remember from last year on Hacky Hours, OpenCV doesn't like red, green, blue. It likes blue, green, red. So that's the way it is. So you just have to remember your results are coming out. This is the Y and the X on the center system on that. So I just get, I'm using NumPy to get what remember the array is going to be, it's going to have 5 channels to it, X, Y, red, green, or blue, green, red in it from a NumPy perspective, if we remember back to our NumPy. So what I'm doing is saying at this channel, I have the X, Y, what are the other 3 channels of the 5? So YX in it. So it's just all that. And CV, X, Y, and to get the colors out. And we have a Hacky Hour on that. So for people that want to learn more about that. So it's just the weirdness of working with the different computer vision libraries. And then we just go ahead and print it out and so forth. So that's really all I have today. We're again open for questions. I tried to make object detection more interesting today with a little color analysis, but I think what everybody wants to see is depth stream. So I don't want to hold up if we're ready to start. Tyga, you ready to go?
Yeah.
Before that, for the model converter in AAI, what frameworks does it support? And it says, I believe it's OpenVINO. Is it OpenVINO?
No.
Yeah.
When you say what are they? So the framework's the OAK framework. We come out and so the natural framework is TensorFlow, and we convert it into the OAK blob, which is a derivative of OpenVINO format. But OpenVINO, I think in their libraries have an intermediate format, so you have to take it down from that. But again,
Yeah.
I should let Tyga or AB talk about this.
Yeah.
No, the question was, sorry, the question was from me. So Steve, sorry. The question what I had was, I saw you used SSD Coco in the OAK model catalog, which you
Yeah.
used it for the
Yeah.
color detection. So you converted that. So it was a TensorFlow model, or was it something else like Onyx model or something else?
I think it was an OpenVINO
It's a
model.
no, yeah. So it's the format was in TensorFlow. The original model, the
Was
SSVB
TensorFlow?
one, yeah, it's TensorFlow. You can
Okay.
find it on the OpenVINO public model catalog.
Oh
But
yeah,
yes,
yeah, yeah. Yeah, that's what I wrote. That I believe that it's only like basically whatever the OpenVINO supports, so that will be all you supported by. Right. Okay. Okay. Yeah.
Yeah, but I should mention the conversion step works directly with our model retraining stuff, right? So
Yes.
if you're kind of know what's going on under the hood, the parameters for that intermediate representation, there's a lot of parameters for different framework types. But what we do support with that conversion command is the outputs of our model retraining. Obviously, you can
Okay.
kind of see online to see how to convert the different models and stuff. But to do that, you would just need to convert it to the OpenVINO version that they support, which I think they are on 2020.1. Yes, so that's the OpenVINO underlying version that you want to target.
Basically, you need the JSON files and all that stuff. So those are the most what to say annoying part of that conversion. So if there's a mismatch, you will land up in a lot of errors. Yeah, I think this applies to any OpenVINO camera, whether it's OAK or whether it's iCloud, OpenNCC. So if that base firmware, whatever they support, that it is very tightly coupled with that. Otherwise, those instruction set, like the optimized bytecode or whatever you said, the ones and zeros cannot be run on that hardware in an accelerated manner. Okay, yeah. So you answered my question. Thank you.
Yeah. Sorry, AB, didn't know what you're asking there on it.
No.
But we do make sure out of our workflow that you hit all the landmines, that you're not going to hit those landmines. So that's
yes. If you use the the model toolkit from alwaysAI, that everything will be covered. So that goes behind the scenes. So nothing needs to be done by the developer. But if you're bringing a model from outside and you want to use this model converter tool, or you want to do it, so then you have to have all those bits and pieces matched with that OpenVINO.
Correct.
Version,
and like you said, the public library can get really interesting in the OpenVINO repository. The Intel ones are pretty sharp and work pretty well.
Yes.
So Micah, I think we're ready for your OAK-G demo.
Cool. Okay. So let me go ahead and share my screen. Share. Cool. Can everyone see that?
Yes.
All right. So I'm gonna be going over the depth stream available on the OAK-G cameras. Steve did a really good job explaining the APIs and showing you how to use the color stream as well as run a model. So I'm just gonna get right into the code here and look at what that is doing. So if I open up, so this is the depth stream application here. Pretty short. Yeah, so let's just go right from the top. So I have an FPS counter. That's the standard EdgeIQ FPS counter that we use in all of our application to keep track of the FPSs. And so you might notice this, like so there's a bug right now. I have a branch that is gonna get rid of this. So right now, you do need to instate the OAK class with a model. Obviously maybe you might not always need a model. So I have a branch in the back that I know kind of gets rid of that. So you can just kind of use the camera and pull out the streams that you want. But right now you do need a model. So that's why that's there. And the important parameter to capture the depth is to set this capture depth equals true. So if you know what's kind of going on and you've used the Sonos APIs before, so there's a camera pipeline object, and what you do is create nodes on the camera pipeline object, and Obviously, you don't want to create nodes that you're not going to be using. So here, when you set this to true, in the back, we create a node to capture the depth stream. And then you have the streamer set as, and it's basically it. So here, we get the depth stream here. This depth, as you can see, it is a, okay, so yeah, this has to be updated, but yeah, so this is also a non-blocking call. So, you might get a none back here. So I'm going to be checking to make sure that it's not a none. And then when, it's not a none, I'm just going to send that to the streamer and then update it. So it's very simple. All you need to do is just get the depth here, the camera.getDepth. And then, yeah, just to make sure that that's not a none return. So let me run this here. So I have already had it configured, and then I've done the install steps. So I can just start it here. And yep, there we go. Yeah, so that is
for everybody. This is a depth stream, right? Not an IR stream. We're just it's a depth stream, so they are different.
Yeah. Yep, and OAK-D uses stereo depth, so they use the 2 cameras, and then calculate the depth stream from there. And so yeah, so that's kind of just like very simple how to use the depth streams on the OAK-D. Yeah, let's see. That's about it from the API standpoint and the depth stream. Is there any questions on the APIs?
Yeah, I believe AB has a question.
Yeah, no, I just have a comment there. So, so this depth stream, so based on this disparity map or this, based on this depth stream, you can also run your inferences. Your AI model also can, predictions can superimpose on this depth stream. So with distance, you can get the distance, how far the object is, whatever you're detecting. So that is the use of this depth stream, despite just having the, and there's no change in the FPS. So it runs in the same high FPS mode. So that is one comment I wanted to add. Yeah.
Yeah. And also there's other usabilities for depth stream. You can kind of do like localization, object avoidance and stuff like that. So it's a lot of cool stuff. The depth stream paired with, your model inferences and those results, you can kind of just, get some cool use cases out of it. Kind of like, getting an unmanned robot out there, and when it detects something that's,
you can do slam.
Yeah, exactly. You can do slam.
Stuff, yeah.
You can just, so it kind of really gives your your unmanned robot or device out there in the field kind of awareness of its environment, and just act better on the model inferences and those results. So yeah, the cool depth stream is really cool. Hopefully you guys can use these APIs to make it really simple to implement depth streams in your application. Use the OAK camera. And
you could also import like ROS nodes as well if you are interested in building robots and all, and try to make like self-driving cars or drones, and not drones. I would never say drones because it's it's scary. But yeah, you can go with the cars for starters. Like it's very, very cool.
Yeah.
So Tygo, what is the max depth limit with OAK-D cameras?
Depth limit with the OAK-D cameras, I think, is around 3. Is it around 3 meters? I would have to pull up their documentations exact. Maybe I can do it.
The claim is, I think 10 meters, but
okay.
you see a drop off about 8 meters, 5 to 8 meters. Correct me if I'm wrong on that, AB. You've worked around it, but I believe that's what you see.
Yeah, and also
that's absolutely correct.
Yeah, and one thing you saw is like I think the depth stream can be calibrated as well. The stream that you saw was not rated, so that may be the reason why there's a lot more holes expected. But yeah, so these cameras can also go through a calibration step, but I did not have a calibrating board to do that. So yeah, one thing I want to mention.
So I think if you order it from their website now, they come factory calibrated, but if you might have got it like a like an early version of that, they were not calibrated to a factory calibration, but they have a nice, like a simple procedure, just to using the checkerboard to calibrate your camera. So basically, it writes the intrinsic parameters, and that really improves the depth aspect of this camera. So yeah, I'm just looking for that. Steve, is exactly right. It's 10 meters, but it's not exactly. Theoretically, it's 10 meters, but it goes like 8 or something. Like I've used
Yeah,
this.
you start to see drop off in accuracies. And I think Aubrey has a really good point that he kind of put up. He said for in-house applications. Yeah, I don't think this is qualified for outside. I'm not sure on that. AB, I'd ask again on it, but I'm not sure how it would operate in the sunlight and so forth on that.
I would say like, okay, there are two things. So one thing with indoor light, like with light of this, like LED lights and all this, like home lights, the depth does not perform very good. Okay, the real sense and Kinect, all they perform much better. The reason behind is this totally uses stereo depth, and it uses that disparity confidence. You need to adjust it, and then lighting plays a very important role to get that accurate depth, which is not the case with real sense, and because they use IR as well.
Yeah.
So they give much accurate results, but there's a cost, there's a trade-off. But real sense cannot do inferences on the camera. All these other cameras, iCloud or even OAK, they can do inferences on the camera. So there's based on your use case, what you need. Second thing is about outdoor. So do you mean like an IP64 or that kind of things, or whether they work nicely on the like an outdoor lighting? You mean
Yeah,
the
I was looking
lighting?
at outdoor lighting, some of the limitations. Like if you looked at the RealSense LiDAR, they absolutely say it will not work outside, right?
Yeah.
And so forth. They're very upfront with what it is. And so I wasn't sure on this one whether this has been.
No, they work decent. They work decent. The first prize, who got the first prize for this, he used it to create an application for disability for a blind like an system for helping the blind to navigate on the roads and all. So he used it for the outside lighting, and it was fine. And even I've just used it for just doing some experiments on the light. So normal light, it works fine, but
Okay.
outside lighting or like inside lighting, like yellow light or like your warm white light or cool white light LED, no, they are not very good. I need to provide proper lighting, so like in consistent lighting. Then the disparity, the depth perspective, the detection, AI model, all those work fine. There's no problem. But the depth is the is the thing because the application which I was building, I needed dimensioning, so I needed proper accurate results. So yeah, so lighting plays a very key role for the depth for the OAK camera, but not for RealSense and Kinect or anything else. So that's the thing you need to keep in your mind. Yeah.
Yep. I think, yeah, and then Gene had the earlier one on the IR. So we'll take a look at, that as a future one with the RealSense. We haven't pulled the RealSense out for a while. So we do have some repo, we do have APIs, we do have support, but I think we'll take a look at probably doing a Hacky hour around that too. So
yeah, that sounds very interesting. Like yeah.
Yeah, that's a really good use case. So I like that.
Awesome. Do we have, okay, one more question. For this OAK camera, is the depth feature only available when detecting an object?
No, what he's showing you is a depth map right now. I think it's on a pixel level, and then I'll let AB correct me if I'm wrong.
Yes, that's correct. Yeah, it's yeah. It can even go to a sub-pixel level as well. they have that feature.
I didn't know that.
Yeah, they have that feature for the sub-pixel level as well, but still in experimental mode. But they have that. But pixel level, definitely yes. Yeah, we had it.
So yeah, so you can find out and move to what they call point cloud. So you can go out and find the information you need to know on a particular pixel depth and so forth.
Yes.
Great. Okay, I hope that was helpful. Are there any other questions or anything else you'd like to share, Steve, Tyga, AB?
No, it was just a lot of fun.
Yeah, a lot of fun. Yeah,
big
really
user
nice.
community.
Really nice, yes.
Really go out and practice your different skill sets, especially around spatial. I think it's just a lot of fun. And as AB says, at an affordable level. So, and again, if you get serious about one of your projects, Lexonis is a really good partner to work with, and they can help you get there to the product design and so forth. So.
Awesome.
Yeah, they have different variants of this camera, like this chip. So they have and you can hook up a camera with an ESP32, which is a microcontroller as well.
Yep.
So that's another variant. Then you can even get a variant where you don't have to buy the full camera with the same distance between the two stereo cameras. You can get individual modules, and you can stick it on based on to get a wide coverage. You can stick those modules on a plate. People have done projects with those kind of things. So it's very much modular. So they can provide you with different kinds of hardware configurations. They are a hardware company, so they can do all that stuff. Yeah.
Yeah, they've been, Tyga's working with them on the MCU piece. I think he can tell you they're a pretty good partner, right, Tyga?
Yeah, it's good stuff. I'm working with a customer on the ESP stuff, and it's really cool. They've done good stuff on, the standalone mode is really cool. The Myriad, the results from the Myriad can be fed to the ESP, and you can kind of just, do stuff kind of like a microcontroller. So yeah, it's really cool. I like that variant.
Yeah, and then if the community we have one less. You opened up talking about lighting. David's got a question for you, AB, on what kind of indoor lighting is best for the OAK-D. So they're going to tap your experience here.
Oh, sure. Yeah. I used a simple lighting. So basically like a studio lighting. So like proper lighting. So in all directions. So, and that consistent lighting helps to get consistent results. So yeah, that's the thing. So I can provide you some of the things I got myself, like simple links, like simple cheap things. And for more professional setup, you definitely need to buy something sophisticated. But for projects like doing at home and all, I have some stuff. I can send you some links from Amazon. You just buy those stuff and it should be okay.
Very good. Cool. And then what I would say to the community, if you have things you want to see in the OAK-D or suggestions on stuff, we'll add things to repos. We'll work on some of the APIs. Just go in and, request a feature on Discord, and we'll try to accommodate and work at it. That way, Tyga will have some idea of what's important for the community and the API side and so forth. So as anything, when we bring something out, it's kind of our swag at what we think we should do and so forth. So, all right, over to you, Cuomo.
I think, Steve, you should make some stickers now.
I should. Great. Well, thank you, AB, for participating, and thank you, Steve and Tyga, for a great demo. I think we all found that very informative. We got lots of feedback saying this was helpful and informative. So thank you, guys. So we do this every Thursday at 10:30 a.m. PST. So yes, the time did change here. So we're about an hour forward. So
yeah, I was about to miss it, and then I got your email.
Yeah, so I know, like, not everywhere, time doesn't change everywhere, but it did here. But we're still here at the same time, to us at least, at 10:30 a.m. So we'll see you then.
We'll be on the same page after 2 weeks.
Yeah, exactly.
Yeah.
All right.
Take care, everyone. Bye.
Yeah, then.
Bye.